Alright, so in the last video we have learned why we need recursion, and we specified various reasons for the need for the recursion. So in this lecture we are going to look at declaration format of recursion and the logic behind it. When we create a recursive method, we need to take into account two conditions. A condition where a method calls itself with a smaller values, and the second condition is to exit from infinite loop. So taking into account these two conditions, the basic syntax of recursion will be like this. So from this syntax we can easily see that mentioned two conditions are implemented over here. So the first one is it checks the given condition. If condition is satisfied, then it returns some value. Otherwise, it continues to call recursive method with modified parameters until the condition met. So if the condition is met, it returns some value and it's not calling it recursively. But if the condition is not met, the method calls itself recursively. So if we miss this condition from here, which is exit from infinite loop, then this method calls itself infinitely. And so this might cause a memory leak in our applications. So before explaining how recursion works internally, let's look at how a normal method works internally. So let's imagine that we have four functions over here. So each of these functions calls one another. So the first function calls the second function, then it prints out that I am the first method. Then the second method calls the third method and it prints out saying that I am the second method. Then the third method calls the fourth method and it prints out that I am the third method, and the fourth method just prints out saying that I am fourth method. So let's see what's happening on the stack when we call these methods. So the stack memory is maintained by the system for the method invocation. You may already know that stack memory works on leave method, which means last entered will be removed first. And here push method is used for insertion and pop method for removal. If you don't know what a stack, we will discuss it in the stack section in detail, so you don't need to worry about that. So here, if we start to call first method, as soon as we call the first method, the first statement that we see within the first method to call the second method is executed. So the controller goes to the second method over here, and after completing the second method, it needs to come back to the first method to execute this line over here, which prints out I am the first method over here. So the system needs to store the first method somewhere to come back for executing the rest of code which is within the first method once the second method execution is done. So to remember the name of the method, the system pushes this first method name to the stack memory. So in this way, the system remembers that it needs to come back to this first method over here. So the first method is pushed to the stack memory. Then it continues to the second method. When we reach the second method, we see that the second method calls third method. So it will go to the third method. But after finishing third method, it needs to come to the second method, because here we have a line of code which prints out this I'm the second method sentence over here. So one more time, system needs to remove this method over here. So this means that once again, the second method will be stored in the stack to come back to execute the print statement after the third method. So second method is stored in the stack. Then we are continuing to the third method. So inside third method, we see that we are calling fourth method and then printing out I am the third method. So this means that it will go to the fourth method. Then after execution the fourth method, it needs to come back to the third method. So somehow it needs to remember the third method. So this means that the system will insert the third method names to the stack memory over here. So the last method is fourth method, which is executing one line of code without calling any function, which means that the system does not need to store it somewhere for calling back. It will not be inserted in the stack memory. So after finishing of the execution of the fourth method, how does the system know that it needs to execute the third method? So we have already mentioned that it will take it from the stack memory. So you might be interested that how the system remembers that the next method should be third method, not the second method. So it remembers it from the stack memory because the stack memory works the way that last in first out. So the last method that we inserted over here will be run the first. So in this case, after fourth method, the system will go to the third method and it will run it and remove it from the stack. So after this statement, we know that the third method is done. So here again, next step is calling from the stack memory, which is the second method. So then the second method will be called and the print statement is executed. So the execution of second method is done. Now system again refers to the stack memory and calls the first method. and executes the print statements after the first method over here, which says that I am the first method. So with this, all methods execution is complete. Now it is clear that how method execution is managed in stack memory. So let's see how a recursion method is stored in stack memory. As an example of method, let's look at this plot over here. So here our base condition is this one. If n is less than 1, that we are printing out saying that n is less than 1. So if it is greater 1, we are calling recursive method with n minus 1, which means that we are making this smaller and printing out n over here. So if we call this function with the parameter of 4, let's see how this will be managed in stack memory. So the first system checks that 4 is less than 1 or not. So we see that 4 is not less than 1. So this means that the recursive method will call itself with n minus 1. So in this case, n minus 1 is 3. So 4 minus 1 is 3. So the method will call itself with the parameter of 3. Now when we call this one, but here you see that we need to print out n over here, which is coming from this method with the parameter of 4. So we need to remember to come back to this method over here. So this means that we will insert this method with the parameter of 4 to the stack memory. Then when we call this method with the parameter of 3, we see that it's not less than 1. So this means that it will call itself with the parameter of n minus 1. So in this case, n minus 1 is 2 because n is 3. Then it needs to remember to come back because here also we need to print out the n. So this means that we will insert recursive method with the parameter of 3 to the stack memory. Then it continues with the parameter of 2. So when it reaches over here, it sees that 2 is greater than 1. So this means that it will call itself with the parameter of 1. So here also it needs to remember the previous one. So this will be inserted in the stack memory. Then when we reach 1, we will call this method. We see that 1 is not less than 1. So this means that the method will be called with the parameter of 0. So the method with the parameter of 1 will be inserted to the stack memory because it needs to come back to print out n over here. So in this case, n is 1. So when we reach the parameter of 0, we see that it's less than 1. So this means that we need to print out n is less than 1. So after printing out it, we need to come back to the previous method. So previous method in the stack memory is a recursive method with the parameter of 1 because the last method that we inserted in the stack memory has to come out first. So this means that the last method is a recursive method with the parameter of 1. So this method will come out. So this means that we will call this method. So when we call this method, we need to print out n. So in this case, n is 1. So we have printed out n. Then it continues to the recursive method with parameter of 2. So in this case, recursive method with the parameter of 2 will be called and n is printed, which is 2, and the recursive method with the parameter of 2 is removed from the stack memory. Then the next method is recursive method with the parameter of 3. So here also you see that it's the recursive method with the parameter of 3. So it prints out 3 and this method is removed from the memory. Then it continues to the 4 and prints out 4 and this method is removed from the stack memory. Now as you can see, all methods from stack are popped out. So this means that recursion stops over here. There is no any method to call again. So this is how the recursive method is managed in stack memory internally. So hopefully everything is clear now. So with this we have come to the end of this lecture. So let's quickly recap what we have learned in this lecture. We have understood that stack memory is used by the system for managing recursive calls. So every time the recursive method calls itself, the system stores it in the stack memory for coming back because there are execution statements left after calling itself. This means that system somehow should remember the point where it stops to call the recursive method with the different parameters based on the condition for coming back. This is done by storing methods in the stack which manage the value based on LIFO method. So LIFO stands for last in first out. And this is all for this lecture, so hopefully you have understood everything. So see you in the next lecture.